is propagating towards right with a speed 3 into 10 to the power of 8 meter per second. I can assume this particular beam of light consists of energy packets. I'll call them as photons. So this particular thing, now this beam of light. So what is this? This is a beam of light. So it is, I'll assume that it consists of energy packets. So these energy packets only, I'll call them as the photons. And what is the velocity of photon? The velocity of light here, that one. In free space. So what is the velocity of the light? 3 into 10 to the power of 8 meter per second. The velocity of photon also will be 3 into 10 to the power of 8 meter per second. Now when I say that energy packet, so means packet word. So sir, how the shape of the photon is still what happened? We are not yet able to confirm it. Will it be a cubical shape? Will it be a spherical? Will it be a spherical or any random, or will it be elliptical or ellipsoidal? So we are not very sure about what can be the shape of the photon, but at least what happened, we have experiments which will confirm that the light, we can also assume it to be made up of a particles called as a photons here. Rather than saying particles, better we can call them as energy packets here. Means till now, the light, what happened, what we have seen in YDSA experiment, in YDS experiment, the light was, so in YDS experiment, so what is the main idea that is involved here? We assume that light is a wave nature, no? Because every point on a wavefront will behave like a source of light, and in fact it will send a wavefront. Will you agree this? Every point, again a point on a wavefront will behave like a secondary source. Again it will start generating the wavefront, and due to superposition, the light energy will move forward here. So this was the idea till now. The wave nature of light is what we discussed in the interference experiment here. Now I know a little bit about that particular. What is lambda? Lambda is the wavelength of light. This is a spherical wavefront. Similarly here, how there's a beam of light. So how the wavefront will be? Shall I put perpendicular lines? For a parallel beam of light, how the wavefront should be like a vertical parallel lines, and the distance between the lines. So that should be the wavefront, or the distance between the vertical lines. So that is nothing but the wavelength what we defined. So here we'll. So what is this dotted red color lines? I'll call that as wavefront here, and the light is propagating in this direction, and this is what the lambda. This is a plane wavefront. This will be a spherical wavefront. Spherical wavefront will come like this, and the distance between this will be the lambda. Earlier what we discussed, that one. Now let's explore further. So instead of this approach, I'm asking you to imagine it is made up of energy packets here. So like, what is the shape of the packet? We are not very sure. We are not very sure. So like, on what basis you are putting some sort of a dot? So it appears as if it's a spherical drop. So just to make students to have some imagination that the beam of light contains energy packets, I'm showing it here. But otherwise what happened? We don't have any experimental proof for the shape of the photon. I'm making things clear, so don't scold me, because if you refer books, no, higher engineering physics books, there the shape of the energy packet still yet to be confirmed. So on what basis you are putting some dot or something? So is it a question mark? To continue to make you to understand concept, I'm assuming some sort of a shape like this. Is it okay? Fine. And these are called as, these energy packets are called as the photons here. And the next question comes like, what is the velocity of the photon? What is the state of photon in that beam of light? They'll propagate with the velocity of light. What is the velocity of the beam of light? That will be the velocity of the photon. So here I'll put one arrow here for any one photon. It is understood. So what is the velocity of photon? That is the velocity of beam of light. So shall I put like this? Photon always travels at a speed of 3 into 10 to the power of 8 meter per second in vacuum. I'll take it off. This may not be important, anyway not useful. So regarding photon, photon travels, photon always travels at a speed of 3 into 10 to the power of 8 meter per second in vacuum. So this is the first idea of the photon. And photon, what is a photon? Photon is an energy packet. What about the mass of photon? So time being, what happened? As far as our mechanics, what we know, classical mechanics, or it is called as Newtonian mechanics. So what all we have is, what all till now we have discussed ourselves called as Newtonian mechanics. In Newtonian mechanics, we say rest mass of photon is zero. Rest mass of photon is zero in Newtonian mechanics or classical mechanics, I'll write it. Classical or Newtonian so and it is associated with the momentum. So what is the energy of the photon is given by h f, where f is the frequency of light, or we can write hc by lambda. Lambda is the wavelength of, see, like a lambda, sir, like a lambda is for what, like for wave nature, no? How can you bring it for photon? S, the energy of photon, the wavelength of light, or the frequency of light. This is like a particle nature. So what this one will reflect some sort of energy packet. This one, what happen, will reflect the wave nature of light here. Or this is like a particle nature. This will be for wave nature. The energy of photon. So like how we define the energy of a light, the similar way, what energy of photon, we are defining it here. The photon will be associated with momentum. What is the state of this photon in the beam of light? What is the state of that? They'll be propagating with the velocity of light. So they must associate with momentum. Then I'll go back to like this. We know E equal to mc square. So this mc into c. This in place of E, what we can write it as, or I'll come in order. mc, what we can write it as, mass into velocity will be momentum, and energy, what we can write it as sc by lambda. So what is the momentum of photon given by h by lambda? So like this, we define the energy of photon and this is a linear momentum of photon. Linear So why you are bringing the idea of momentum? We know that photon is in motion and it contains energy. So I'm able to express that momentum in terms of energy that one. So shall I say that the momentum is the main parameter? Because can we have photon at rest? So what all the energy of photon is due to momentum, no? Is it, shall we say a photon is at rest? Nothing, it's a meaningless thing. And also whenever you say a photon should have momentum. And it will be in motion, that one. So therefore, what all the energy of photon is due to momentum. This is what the Newtonian mechanics will put a limit, because P equal to mv. We say like that. But in the modern physics now, we have to come out of this little bit classical mechanics. We have to come out of the classical mechanics, what we have. The rest mass of photon in Newtonian mechanics is zero. In quantum mechanics, it is defined here. So as far as our level of physics concerned, we'll call it to be zero. So I'm bringing expression here, no? The momentum of photon. A simplest idea, can we have light beam at rest? No, light beam will be always propagating, no? And the light beam made up of photons, so the photons must always be propagating. So the photon must have momentum non-zero, and that I'm giving expression like this here. So in Newtonian mechanics, the rest mass is what? Zero. Means as far as our syllabus is concerned, rest mass of the photon, you can take it for zero. In quantum mechanics, it is defined here. Okay, this is about the regarding the that energy packet, what that is called as a photon, and where h is a Planck's constant. I think all of you know the value of this. Value of h 6.626 into 10 to power of minus 34 joule. Very frequently I'll be using this value, 6.626 into 10 to power of minus 34 joule per second. Now, what about the energy of all photons in this beam of light? Will be same. Means if you look at this, so like what is the energy of this photon and what is the energy of this photon? I'll give number, photon 1, 2, some random I'm giving number. What is the energy of all photons in this beam of light? Will be same. What is the momentum of all photons in this beam of light? Will be same. Say a beam of light of wavelength lambda, all photons in that must have energy. How much? Sc by lambda must have energy, or the momentum h by lambda. So it's not like one photon will have more, other photon will be less. Then the average is what we are putting. No, all the photons in a beam of light must have same beam of light of wavelength lambda must have same energy and momentum. And next again, will these photons, will they interact with electric and magnetic field? The answer is no. They will not be deflected by electric and magnetic field. The photons will not interact with any electric or magnetic field. So shall we say what is the charge of a photon? Should be zero. Will not. Photons are not deflected by. I'll write electromagnetic field. I think it's okay. You pass this beam of light to electric field. Will the beam of light will get deflected? The answer is no. If you pass this beam of light through magnetic field, will get deflected? Will not. So therefore, similarly, I can say same thing for photon. So photons are now deflected by electromagnetic field. So what is the charge of a photon? We can just put at our level 0. And next again, if the photon this is sorry. Yeah. Joule second, it should be here. Photons are not deflected by electromagnetic field. Next again, what about the photons here? I think you know a little bit about the atomic structure. If a photon goes in, so the atom and electron, what happen? Let it be there in the first order state. Now there's a photon. There's a lambda. There's a photon here. Huh? If I show like this, it's understood it's a photon. It will go an incident on a atom in the ground state, hydrogen atom in ground state. It will get excited to say n equal to say 3. Then again this particular atom what happen will come to ground state. No, when it's coming to ground state, what it can do? this atom, how it can make transition. So here, this is n equal to 1, n equal to 2, n equal to 3. It can make transition directly from 3 to 1 or 3 to 2, then 2 to 1. Here it will give out one photon, lambda 3 2. Here lambda 3 1. Or it may directly make a transition lambda 3 1. So anything can happen, no? This one. So now you see that if this atom, which is in ground state, if it absorbs the incident photon, and if it gets excited to higher or higher state, so let it be second excited state, or we'll call that as n equal to 3, then it will de-excite. When it de-excitation, so it may directly move from n equal to 3 to 1. In that case, it will emit only one photon. Then in another situation, what happen, it may happen like this: first from n equal to 3 to 2, then 2 to 1. How many photons will be generated when it changes state from n equal to 3 to 2 to 1 2? How many photons will be generated when it changes state from directly from 3 to 1 1? So is it number of photons must be conserved when a photon interacts with a material. This atom is like a material. I can call different. So when a photon interacts with a material, so number of photons must be conserved, need not, no? Or if it jumps from n equal to 1 to n equal to 4. So if I make it n equal to 4, then what happens? It may give out 3 photons, the item. So number of photons need not be conserved here. So we should not bother like when a photon incident on a material. Then shall we try to think about anything about conservation of number of photons? Nothing, no? Like we started electrostatics with what? Law of conservation of charge principle. So anything about here, the photon conservation, you need not to bother. Just like I said, these many photons are incident. Then what will happen? Those many photons. You need to bother about conservation of photons. It's quite meaningless idea here. So here, number of photons, when a photon interacts with a matter, number of photons need not be conserved. So shall I put another statement? I'll put it here. When photons interact with a matter, number of photons may not be conserved. And we need not to bother also about this particular thing. Now here you can see the way I am writing things, photon, and I'm saying matter. Sir, photon is not a matter. No, photon is a energy packet. I think somewhere first. No, here it is there. No, matter is different than energy is different here. So here what happened? Like a matter is another form of energy only. Later on, from Einstein's equation, equal to mc square. Matter is another form of energy only. So here the photon exclusive, I'll call it as energy packet. Very exclusive, I'm going to call it as energy packet here. So when photons interact with a matter, number of photons may not be conserved. So we need not to bother about this aspect here. That's what he's saying. Okay, after this. Okay, let's go back to the very general idea of like how to generate number of photons, like then all other parameters here. So let me go for intensity, this one here.